Hello and welcome to a late night recording of Fully Charged, a Fully Charged special. We've stayed up very late. We're actually watching the live Tesla announcement about the new battery stuff they're doing. It's quite impressive already. There's been so many rumours. So we'll go through them quickly. I'm with Roger Atkins, who has more followers on LinkedIn than any other human being in the history of the human existence. It's just extraordinary. And he's got specially dressed up to... He's basically supporting the Texas Gigafactory. I think that's, it's an homage to the Texas Gigafactory.
Yes. I thought I'd dress up like Elon's brother. So this is me as Kimball Musk.
Kimball Musk. It's a very good impression. I thought you were Kimball Musk for a moment. But we've just been watching this, and it's obviously been going on for quite a while. But they've now finally announced the things that caught my ear from the beginning of this presentation: half the cost of current batteries per kilowatt hour, which is pretty impressive. If they can achieve all this, shingled tabs. I don't think we need to go into shingled tabs, but when they explained it, I kind of understood. It's a cheaper way of manufacturing. It's all about improving the manufacturing process, I think, rather than necessarily the materials within them, and a different size cell, and then a 16% range increase in weight and volume. So if you have I wish I was quick at percentages, but if you have a car that can do 300 miles an hour and you increase that by 16%,
it's 48.
Is it 48? So it's 300. So it's basically 350 miles is what you're looking at around that.
Yeah.
How can you do maths like that? It's because you're wearing that hat.
Yeah, it's the hat. It's got a special calculator built inside the hat. And perhaps, Rob, just before we get into the meat and potatoes of Battery Day, what we should explain is that here in the UK now, really we are breaking the law because I think it's either from today or from Thursday, we all have to go to bed at 10 o'clock at night.
And it's now just gone 11, so we're up late.
Yeah, we're breaking the law, Rob.
Oh, God.
I'm inside a room with all the screens down because I don't want anyone to see me in here, obviously, But anyway, yes, Battery Day. Battery Day now. Yes.
But so I'm
going to take the silly hat off, actually, Rob.
It's up to you. I mean,
because I can't see you.
No, that's true. If you can't see, that's not so good.
Thank you.
Yeah. But that, just those sort of basic things are... Because that's what I was expecting. So I know that you've been talking about the supply of materials, securing the material supply, which I imagine they will mention later. But this is the sort of the rumours that I was hearing, that they were going to show a higher energy density, different battery designs. But now they're doing powder to film. So that is what you were talking about, is where these materials come from, how they're refined, where they're refined, basically China, South Korea a bit, but mainly China, isn't it, at the moment?
Yeah, look, China's dominated this stuff. You and I both have been alerted to it, as many others have, by Simon Moores and Benchmark Mineral Intelligence. So, this dominance of China isn't good for China in reality. It's just kind of evolved that way, but it's definitely not good for the rest of the world. Yeah. And it certainly isn't good for Tesla. So I think what we're going to hear is them doing something about that. But to quickly backtrack to where you were with things, what they did say is they're going to announce a number of things that combine together give you this extra energy density, the benefit of reducing cost, etc., all towards that journey of, as Elon says many, many times, accelerating the adoption of low carbon vehicle technologies. And that's what it's all about. So the form factor, as they briefly explained, you've gone from, this sort of size, 18650, to a bit bigger, 21700, and then an even bigger one. I think Simon called it, I don't know if it's the official name, the biscuit tin, because it looks like a biscuit tin now rather than a battery.
Well, it's 4680. So that so they would have called that 460-800 is what it would have been. And it's really confusing because they add another naught, but it's 46 centimetres by 80 centimetres, I'm assuming.
Yes.
So it's quite a bit bigger.
Well, I know when Simon first said it was called the biscuit tin, I was very interested in that, and it really caught my attention because, of course, I really like biscuits. Yeah. So, it's fascinating. But, where else, Rob, would you get the CEO of an OEM on stage with one of his senior team going through methodically the kind of realizing the strategy of how they're going to progress their business.
Yeah.
I guess with some form of script, but not much.
Yes.
They're doing it because they know their stuff.
Yeah.
And I think this is one of the big attractions of people, whether investors or otherwise in Tesla, is that he stands up there, and so do his team from time to time, and they just kind of hoof it.
Yeah.
But they're really talking about what they're talking about every day. That's why they can just freestyle it.
But it's also that, I think, the fascinating thing he said in the first part before they started talking about batteries, it's that overarching aim of the company, of him, because I sometimes get a bit moody about Tesla because they get so much attention, but you've got to hand it to them. There's no other boss of a big manufacturing company that says the whole purpose of our existence is to produce technology that does less damage to the planet. The core reasoning behind why we're doing this is for that, which is what he always says that. And I always forget in between hearing him talk. That's always what we want to have, energy that doesn't require burning stuff, that doesn't require digging, drilling and burning. And that's their whole motivation is for that. It is extraordinary.
Well, you're right. Yeah, yes, it is. And that's because they haven't got legacy.
Yeah.
Because they're not an incumbent. They're not on the journey of transition.
Yeah.
It's because they've started with a clean sheet. I think, and what I hope we're going to hear some of shortly in the future, is that they equally understand that you can't just transition from digging up oil and coal to digging up, whether it's lithium or whether it's cobalt or whether it's, manganese, whatever, that they're looking for more sustainable ways to do that, both the mining and the processing of the minerals, and equally to reduce the carbon footprint by localizing that as much as you possibly can, so...
And then also being able to reuse those materials at the end of life, which is critically important, which they have mentioned. They haven't mentioned that more recently, but they did mention it earlier on.
Well, they haven't, but you know the name J.B. Struble?
Yeah.
J.B. Struble?
That's his
company. I
could
never say his name, right?
Yes, I never know how
Redwood.
to say it, yeah.
Exactly.
Yeah.
So he left the company, I'm sure, without any kind of ill whatever, and started up this company now, which I think is going to be very important to, again, Tesla's journey, Redwood, to recycle and reuse. Because, again, unless you're honourably tackling the issue of climate change and clean and air quality, you have to dig deep, literally, no pun intended, right the way back up into the supply chain, and also, reuse and recycling. Yeah. So, again, this is just not what you hear from other people. They talk about the principles of it, but they don't put in place the technologies or the companies, or indeed the investment, to actually then get on with it.
Yeah. No, it is amazing. I think one of the key little things I heard them say, which I did understand I think we've probably got a similar, I would like to say, very high level of understanding of the kind of the microphysics of battery technology. But I do understand that if you can reduce the distance an electron has to travel within a battery, you get a faster, a more powerful battery, and you get a higher energy density. And that is that was one of the key things they said. We've managed to reduce the distance an electron has to travel between the cathode and the anode, which is, by the way it's rolled up, it's because there's so much information here that we're not going to be able to communicate. I realise as I'm saying this, I'm digging myself a very big hole. But with an electrically powered backhoe digger. So,
Yeah, but I think what's important, Rob, is to share with your amazing audience, and a lot of them are engineers, they're chemists, they're really clever people, and lots who perhaps haven't got quite such specialist knowledge, is that this is an important event. Yeah. This isn't just a hype event to jump up the share price
or
a bit
launching
more.
a new car style or something.
Yeah.
No, it's very
this is a genuine update on a number of developments, commercial and technical, that the company are doing that they want to share.
Yeah.
And why are they doing that? Well, of course they want to tell their investors and their customers. Yeah. And you can hear the hooting cars, so they want to tell the cars as well.
But that, I think, because that's the other thing that I always find intriguing is when I know we've both been party to it, either at conferences or discussion groups or comments on YouTube or whatever, there aren't enough materials, or we're going to run out of lithium and all those things. And I think that I'm questioning whether they would invest the amount of time, energy and money in producing lithium-ion battery cells by the billion if they thought, well, we're only going to be able to do this for 2 years, then we're going to run out of material. I think they know. That's what I'm saying. And people like Simon Moores, they know how many batteries we really can make, how many, gigawatt hours we can produce. And it is substantial.
They do, and let's not forget that batteries aren't just for electric cars.
Yeah.
So therefore, they're the machines we're looking at right now. These laptops, they're for mobile phones. They're for, crucially, and I think you could almost argue most importantly, they are for stationary storage.
Yeah.
To go on this journey of eventually having, as near as damn it, complete renewable energy feeding the global grid, the entire planet, but that is predicated on the ability to store it efficiently, cheaply, safely, and all of those things.
Yeah.
So I think the metrics, Rob, fundamentally are about putting together those different aspects of what a battery is going to be used for, and then working out again, use of those things and reuse and recycle. And the bee in my bonnet about, I don't necessarily think that the whole world will switch to owning an electric car because of the arrival of sharing or autonomy, etc. So I don't think necessarily we're going to have to go on a journey of making 1-point-something billion electric cars and all of those batteries. I think it will be a different journey forward in terms of how that works, but for sure we'll still need an absolute pile of batteries to make all this stuff work. And you were talking to Jonathan Porritt the other day on your podcast. I've listened to a lot of those. They're really good, by the way. The Dave Hunt one is fantastic, and the Jonathan Porritt one too. We can't ignore that making batteries has some challenges. So let's be honest about what they are, and then let's tackle them, which I think is what we're seeing a slide here saying.
That is very interesting.
This is what they're talking about.
Yeah, the Gigafactory in Nevada produces so many gigawatt hours a year, isn't it? When they did the Terafactory, that's the one in Austin. Going, what's that called? Why is it called that? Well, that produces a terawatt hour of battery storage a year, which is, at the moment, mind-boggling. I'm sure it won't be that. But what then that other most recent thing is how many, I can't quite see, I missed how many terawatt hours they'll be making a year by 2030. It's a lot.
It says three terawatts.
3 terawatt hours a year. Because the world uses, at any one moment, is using about a terawatt, isn't it? I think globally. I mean, it's a lot of electricity. We're using just over 2 terawatts at any one moment in the whole world.
Yeah. Or as they'd say in America, Rob, or California, a whole bunch of electrons, a whole bunch of electricity. Yes, they always say a bunch of something, a bunch of anything, don't they? I like that though. It nice. Makes it sound fun.
We would say an awfully.
All right, so look here, look,
big pile.
Yeah, this is an interesting slide. Look at this one.
All right. Silicon. Well, because I think it's worth reminding ourselves what silicon is. Sand, basically.
Yes.
So there's quite a lot of that around. But that is interesting. If they're talking about using silicon, because that's what there's all these potential battery. There is graphene,
silicon anode,
graphite, silicon anode. Silicon structured in graphite. I mean, it is such a hyper nerdy presentation, isn't it? Because you couldn't. It's such a confusing combination of sort of super, commercial populism and incredibly detailed science and nerdiness.
Well, it is, but I think what it starts to show you is something that you will have heard from people like Peter Bruce at Oxford University,
yes.
The real kind of boffins of batteries, who will have been telling you, because they've been telling me and others, that, if you think of ultimate battery, if we can have an ultimate battery, super duper, great energy density, etc., say within the next decade, and that's a scale of 1 to 10, so that super duper's 10. We're only about 3 or 4. So what these guys are showing us here is how do we get to 5? How do we get to 6? They're actually showing us the steps along the way, the pathway to getting to that, super duper 10 battery, which the battery boffins tell you we will get to. It's about what materials you put in the anode and the cathode. It's about the form factor. It's about, all of those component parts, which is what they're, explaining. And And yeah, this is where you get. So what have we got here? We designed for expansion and use raw silicon to increase range by 20%. So as you said earlier, 300-mile battery, 20%. There you go, 60 miles.
Another
Bosh.
60 miles, right? Yeah. And it's also, I mean, one of the slides I just saw, and I cannot believe I saw that right, but it was saying $1.2 per kilowatt hour. Well, whether that is manufacturing cost, because that is ridiculous, because at the moment, what are we looking at per kilowatt hour? About $120 a kilowatt hour manufacturing.
It depends who you talk to, and I think, again, that you've got to remember that different metrics on that. That's at the cell level or the pack level. Right. It depends which one of those that you're talking about. But so this is interesting. That, as you say, it is kind of nerdy, but not massively so, because it's explaining in kind of layman's terms what is an anode, what is a cathode. How does that work between, taking the electrons, the energy in, holding it, and then delivering it, and then charging back up again. So, and again, putting in the metal. All right, this is interesting. Yeah. Showing on a graph, graphical X and Y axis, where, the cost is cobalt, nickel, etc. And again, this is where the work that Simon and the guys at Benchmark have done is so absolutely really massively important. It's forensic analysis of not just cost, but availability, quality,
or geography of where it is.
Geography, absolutely, because you've more and more now we have to have, and we are seeing absolutely ethical mining.
Yeah,
and you can say, well, surely all mining isn't ethical because it's scraping the ground or digging up great big holes or whatever. But if you start to get under the skin of what's happening, people are having to make good what they do. They're having to put money into some of the local areas where they come and take away some of that resource. So there's a real big backstory to this. How do batteries get made? What stuff goes in them? It's too simplistic to just say artisanal mining of cobalt in Congo is bad, so all batteries are bad, and that's the end of it. Yeah. It's there's a lot more than that to it.
Yeah. Which is quite interesting. That is you don't have one type of battery. What they're showing there, for everything.
You've seen that now in China, Rob. That's a very good point. It isn't one size fits all or one chemistry fits all. So, for example, LFP battery is what they're putting into the Model 3 now in China, and that had gone back from nickel manganese chemistry, and the reason they were doing that was because they could reduce the cost and the inherent capability of those sort of batteries, that's chemistry, works particularly well when you have, relatively low range and relatively repeatable sort of duty cycle. Right. And funnily enough, ModelX, you remember the ModelX vans in the UK, they were using lithium iron phosphate batteries, LiFePO 4, LFP, like 10 way back in 2007-8, 12 years ago. And those batteries still work in a lot of UPS vehicles and a few other places around the world. So, picking the right chemistry for the battery to get the right price, to deliver the right proposition. It's not just, this battery chemistry full stop. Yeah. So having the ability to be flexible in your manufacturing process and put it into the right product. Again, this is what these guys are doing and no one else is.
Yeah. So I was prepared. I was being a little bit cynical before this started, Roger, and I was being a bit sort of, I bet it's not as big a deal. I think if they can halve the cost, add 16 to 20% of energy density out as in range, and come up with a completely new battery design, effectively, that is extraordinary. It is a game-changing moment.
It is, but I think this is just the kind of, next chapter in the Tesla story. They start with an electric vehicle, and we see that for a number of years. Then we see the announcement of Gigafactory, battery manufacturing facilities. And now tonight we've heard about where they are with chemistry, where they are with supply chain, and actually looking at expanding that ability to ensure that when they have all these gigafactories to make all these electric vehicles, they've got security of supply and capability in and around that. So we've seen kind of a number of things that all, when you add them all up, add to reduce costs, better performance, and another step change that kind of leaves the traditional OEMs, let's be blunt about this, kind of in the dust.
Yeah.
So, I'm sure there will be plenty of people in various countries, Germany, I'm thinking of particularly, Japan and elsewhere, putting their head in the hands tomorrow, thinking it wasn't hype. This wasn't some kind of, razzmatazz thing. This is about commercial, technical, operational step change. Yeah. And that's going to kind of, freak them out.
It is really, because I would not want to be in competition with them, because they just, this is a leap so far ahead. Every other manufacturer everyone is reliant on an external battery supplier, 100% reliant on it. And if they can't get those batteries, they can't make the cars. And we now know beyond question there is demand for these cars. There is. People want them, and there's all I hear about is, I'd love a whatever manufacturer, but I can't get one. There's a waiting list, and you just go,
yes.
And what is holding that up? It's batteries. They all say we can't get the batteries.
Well, look, we've heard a lot tonight, Rob. Yeah. So obviously we can't talk about it all. No. But one thing that Elon said that really stuck in my mind was he really cares and wants to deliver that, lower price electric vehicle. Okay, the Model 3 is selling like hotcakes, but it's still for many people that 5-10 grand too much. Yeah. And what struck me was the way he said what his ambition was to truly fulfill that sort of affordable electric car ambition. What we've heard tonight is, if you like, the building blocks of being in a position to do that. Yeah. So they haven't announced a new model. They haven't said, this is the price, $20,000 or something. But I think pretty much this brings together the capability to do that quite soon, probably sooner than a lot of people expected. Yeah. So, I think it's extraordinary. But, when you can land a rocket back on the ground, or you can go and, be the customer for, work with NASA like they do, and all these other things, why would be surprised? Yeah. Be surprised. Yeah. I want a Neuralink chip, by the way, quite soon. They do that.
I want you to have one so I can see what happens when you put it in.
I volunteer. I'm putting my hand up right now.
That's great. But anyway, Roger, thanks very much for staying up with me tonight. It's been. I'm really glad we did. It has been extraordinary. And
I've been helped with a glass of whiskey, by the way. I must confess that.
All I've got is my tea in my Land Rover mug. But there we go. There you go. Should have put a drop of brandy in it. I forgot.
Yes.
Anyway, that's brilliant.
Pleasure doing the night shift with you.
Thank you. Yes.
And I would recommend everybody listen to these podcasts. I listened to a whole bunch. I had several hours travelling, and like I said, I listened to 3 or 4 on the bounce, and they're so good.
Thank you, Roger. Well, I want you to be a regular on it, because I think it'd be great. We can chew the fat every now and then on the Fully Charged.
I've got plenty of fat to chew, Rob, so that'd be easy.
I've got a bit of extra. Anyway, that's very good. All right, thanks so much, Roger. Great stuff. Good. Take care. See you soon.
Thank you. Goodbye.
Well, I want to thank Roger for doing that. If you're on LinkedIn, if you just look for Roger Atkins, he posts amazing stuff on there. He's really good. He knows everyone. He knows everyone. Elon is still going on that cell vehicle integration. It is amazing what they're doing. You can probably find their whole video. It's long. The whole video of this announcement is on YouTube. They keep coming out with more and more information about it. It is remarkable, but it's very, very late now. I'm going to go to bed. So all the normal caveats. Please do subscribe to Fully Charged. Have a look at the Patreon link. All that stuff. And as always, if you have been, thank you for watching.